Okay, this way you can go for the exam. Okay, so this is how depth first works. Again, for breadth first, say, let me write this one, 2, 0, 3, and 4. They're connected. Okay. So now in breadth first, what we'll do, you'll first come to, say, someone give you that please start from node 1. Okay. So for that, what we'll do, you'll first add both of your neighbors. So it theoretically it can be in any order. So your 0 2 can you can add 0 2, or you can add 2 0 also. But most of the times in implementation, you you may have some weight associated with these edges. Okay, so based on those edges, you will give preference one over other. Okay, so now, for example, say for this example only, it is being asked like, you please consider in a sorted order. If you have any choice, you take which is smaller. Okay, the node with smaller value. So here for that, okay. So we'll take 0 and 2. Okay. So after you take 0 and 2, what will do? One has these two neighbors only, 0 and 2. Okay. So after it's all the neighbors are added, what you will do? You will check this list. You go to this list and look from the left side. Okay. From the left side, you have 0. So remove this 0. You can have a separate list here. Okay. You can have a separate list here to how we are visiting nodes 0 to we already visit. From this is the separate for solving the questions I'm saying. You can come here and you remove this 0. Okay. After removing 0, check from you remove 0 and check go to 0 and check its neighbor. Its neighbors are 1 and 2. From there, both these are actually visited. So actually, I forgot to tell you initially that when we are starting the process, we have to add this node also 1. So sorry, actually I forgot previously. So okay, let me start again how it will work from the beginning. So at starting, you will have 1 only. Okay, given. So you will remove 1. You will remove 1 and you check its neighbors. Okay, and there is a separate list to check the sequence of node visited. Okay, so first we visited 1, and this is a separate list from where we take one node at a time. So you remove 1 and you'll check who are the neighbors. Neighbors are 0
0
and
and
2.
2.
Since I said in the sorted order, then what you'll do? Okay, these two are added. Since all these neighbors are explored, you will remove the you look from the left side and remove the next element, which is 0. And from after coming 0, see all its neighbors are explored. So one, sorry, 0 2. Okay. Now you don't have anything to explore here, because already 2 is explored and 1 is explored in the first test step only. You will then go to you'll remove the next element 2. Okay. So once you remove 2, now you again see who are the neighbors. Can you please tell me who are the neighbors?
1, 0, 3, and 4. 1 and 0 are visited.
Yeah,
3
one.
and 4 are yes.
Everyone is its neighbor, but
Yes.
1 and 0 are already visited. 3 4 are remaining. So again,
Yes.
we'll in which order we'll add 3 4 or
3 and
4 3?
4. 3 and 4.
3 and 4. Okay, 3 and 4 will come here. Again, I closed it because I'm okay. Anyway, now again, its neighbors are explored. So what we'll do? You'll again look from the left side. You remove 3 and see. For 3, there is no neighbors. There are neighbors actually 2, but which is already explored. Sorry, to add here also. Then okay, where it is? So you remove 3. You come here and you check. Okay, its neighbors only 2, which is already explored. Then so nothing to do with. You will again, if there is any neighbor, you will add in the right side. Okay, that's it only. So if no neighbors are there which are not explored, sorry, visited, you will just simply go back and you will again remove the next node, which is 4. Okay, so remove 4. Again, from 4, again you check the neighbor is 2, which is already explored, so nothing to do with. So this is our the sequence of node visited. Now, based on your uh, first visiting order, this order may change. Okay, because consider, say here, instead of visiting 0, if you visit 2, then you could have gone 1, then 2, then from 2 for the first search I'm saying. Let me divide. Uh, so for the first search, what you can do, you first saw 1. I mean, you started with 1, and then from 1 you saw the neighbors are 0 and 2, but you first decided to take 2. Okay, so then you'll, from 1 you will go to 2, and from 2 again you have 2 options. You can take any one. Say you again took 4. Okay, so then you, what you'll do, from 4 there is no more nodes. Okay, so you'll go back, to 2, and from 2 you'll see who is the next neighbor. 3, you add in this order. Actually it is coming after 2, but here I'm checking the sequence only, in which sequence I'm visiting them. So then 3 will come. From 3 again you don't have any neighbors which are not explored. Then you'll go to back to 2, and from 2 you see everything is explored. You can I mean, for
0 is remaining
pseudocode for
zero.
programming, uh, for pseudocode or programming I'm saying, you can maintain some flags based on which you will decide whether it is visited or not. Okay, so you will go here, and then all the neighbors of 2 is explored, and you'll go back to 1, and from 1 if you see uh, 0 is 2 is explored, but not 0. Okay, so you'll add 0 here. Okay, so this sequence will change. So in questions you may ask, like, given this graph, what are the different sequence possible with DFS or BFS? Okay, so this is uh, one shortcut. If I didn't make it complex, one shortcut you can follow. Okay. So any question here?
No, no, sir.
Okay. So again, there's a small concept here. Again, something called tree. So a tree is, say, similar to graph. Only thing is, like, the graphs are closed, but tree is actually not. So if you don't have this edge, it's more like a tree only. Okay. So and again, you may have heard about one concept called spanning tree in lectures. So spanning tree says basically uh, like how many minimum edges you require to connect all the nodes. Okay. So for that also there are just some algorithms called Frames, Kroskal. So these things are not in the syllabus, but
It
yeah,
is in maths,
they
sir.
exist.
It is in
Okay.
maths.
Okay. Okay. So let's go to the this thing now. Practice assignment. Week 11. ABC, practice, practice assignment.
Sir, I have a doubt on the graded assignment question.
Grade assignment.
Yes, sir.
So which one? Let us solve practice assignment first.
Sir, practice. Okay, okay, sir. Okay. No.
Okay, so the first question is unique is a procedure that accepts a list as input. It returns the unique elements in the list after removing duplicates. Okay, select the correct code fragment to complete the pseudocode. Okay, so they're saying this is a procedure unique L. They're taking they're initializing one list with the empty list and then saying I hope everyone remember this list operations, right? This first, last, then
Yes, sir.
rest.
Yes, sir.
Yes, sir.
What else was there? Length is there. Okay. So what they're saying, if the length is less than equals to 0, then they are returning the L. Okay. So they are basically saying, like, if you have only one element, then there's no element or one element. There's no need of uh, uh, removing any duplicate. Okay.
Yes, sir. Basically, the
So,
return L is going to that calling procedure that we are calling here.
no, not. It's not calling. It's returning. It's going back to initial position.
So
Okay.
it's return back
So
to the initial procedure or the sir, the procedure we are calling in that procedure.
So the procedure when
from
you
that position,
yeah.
from
So
where
when the
you call
procedure
this procedure.
Yeah, that's what I'm
when
saying.
the sir unique list will have only one element, or then the procedure will be called, it will stop over there only. It will return the value of L, and that will get stored over there. That we will have to run this entire. We will have to find this code, sir, first, and we will
Uh, hmm. So yeah, first is like this is basically uh,
last step, sir.
cons- uh, no, yeah, we'll go there. So this is just handling some edge cases. Okay. So you may have n number of elements in list, but sometime someone can give you empty list or single element in a list also. So for
Yeah.
that you have to handle these things. Okay. So then what they're saying next is init elements is init of L. So init of L will give you the initial part of uh, this list L. Okay. So it will remove just the last element, if I'm not wrong.
Yes, sir, correct.
Okay. Uh, so
The
next,
option one is correct, I think, in the case of return
let's
unique.
see.
Yeah.
Uh, okay. So let's see if it is correct. So here they're saying if member of element and last of L. Okay. So member is again a function which returns true or false based on if the given element is a member of a list. Okay. So the first argument here is a list, and the second argument is a number. Okay, number of or item, basically because your list can have any data type, right? It can have list. It can have even combinations of integer, string, float, but most of the times we stick to one data type. That's why I said item here, because I didn't say number. Okay, so let's go. What they're saying,
So
if
you can take
the
an example like a list of
element,
1 to 1, then it's easy to
uh,
check.
okay. That's better.
Yeah.
Let me go. Okay, so then in that case, I have to switch multiple times here and there. Anyway, uh, I have to add one slide, I guess.
So it will be better if you download the paper and just annotate on the PDF.
Oh, that is also a better option. Oh, for some reason, it is not printing all
I
the.
think, sir, the download option is there on when you, sir, scroll upwards, sir, on the portal only, sir.
Okay.
Okay, cancel it. Yes. Yes, sir. It is over here, sir. Click the download PDF version of the questions.
Where? Okay.
Yeah,
Yes.
middle.
Okay. Yeah, let's go to the first question. So here I have to now I hope I can write. Oh, still I'm not able to write here.
Sir,
Okay,
try to
first,
open this
I'm not
PDF.
able to write.
So try to open
Sorry,
this PDF on the Microsoft Edge, sir.
using Edge you're saying.
So press the right click, sir. Yes, open with.
Mhm.
There is a Microsoft Edge. Yes. Here there is option to annotate on the PDFs.
Okay, these things I have to select, right?
That's a highlighter, sir. The draw option use. Yeah.
Yes.
Yeah.
Okay. Yes. Yes.
Yes, sir.
Okay, fine. Let me just maximize it. Okay. Yeah. So here we have say list 1 comma 2 comma 2 comma 4. Okay. So what this first procedure will do, it will check if L is the member of uh, initial item. Sorry, init elements. That means the first n minus 1 element. If n elements are there in the list, it will check with the n minus 1 first element. If it is there, then it is returning unique of elements. So okay, so that's fine, because if this element is already exist in uh, the first n minus 1 element, then we just can skip this last one. So here say we have 2. Okay, so I think someone is not mute. Some noise is coming. Can you please mute yourself? Oh, thank you. So what will happen? Say we have this 2. This last is 2. Okay. Now what will be our init? Init is 1 comma 2 comma 2 comma 4. Okay, and we are checking with 2. When you check with this 2 is the member, it will return true. Okay, so that means like we can ignore this. So they are again calling the same function unique. Everyone, please mute yourself if you are not asking any question. Okay, so what will do? It will continue with the rest of the elements. Okay, so that's why it is calling the same function unique with the init elements. Okay, so the next time what will happen? Again, these elements will come. Now, again, what it will check? Okay, again it will check take the last element 4, and the init will be 1 comma 2 comma 2. Okay, now the query will result false. Okay, so then in that case, what it will do, it will say unique of unique elements, these elements plus list. Okay, but there's a issue here. If anyone saying correct. I mean, the logic is the logic wise is correct, like what to do, but there's one syntactical issue here. Can anyone tell me what? Hello.
Sir, could you please come again? What you say?
I said okay. So in this case, if you see, 4 is not an element of this init.
Yeah.
Okay, so it will result false here. So when
We
it
will
results
go to
false,
else part.
we'll go to this section. We'll go to
This
this
part.
section, and this section is saying unique of the rest of the initial elements, which is fine, because we here also we are calling this, which is fine.
Yeah.
But it is adding the next element, which is again conceptually correct, because we have to keep this element. Okay, that's why they are adding this. We have to keep this element, and from the rest of the list, sorry, not rest, initial list, we have to remove the duplicates. So they are calling the unique element init function with this list to remove all the duplicate element. But 4 is one unique element. That's why they are adding this unique element at the end. That I'm saying. But there is one syntactical error.
So the list
This answer seems correct.
the list box is missing else condition. The list box is missing else condition.
Exactly,
No,
exactly.
yeah, init element will return a list, and we have to add the last elements will be also in list only.
No, the last will return what? Last will return you item. One
No, sir.
item,
I'm
right?
saying, sir,
So in this case,
to add in a list, we need a list only, which is not there.
Yes, sir. The last stop L
okay,
is not
okay.
in the. Yeah.
Yes. Okay, fine. Yeah, that is the issue. So, for this reason only, uh, it is not correct. Let's go to the next. Next, saying the same thing, but here you can
Is it in
see.
the list in that case?
So if L is in the list, they are just return init elements. Okay.
Yes, sir. There is a
So
mistake.
this is
There
not
unique.
correct,
It need to
because
return to
Unique is
unique L.
missing.
uh, so for the rest of the elements also, we have to find if it is if all the elements are unique or not. Okay. So that is the mistake here.
Sir,
Then
for this, sir, option B. Suppose if this pseudocode we are working on this pseudocode only, sir, it will just check the last element and then it will stop, right?
yes.
Sir,
No,
this
it will check the last element. See, we cannot guarantee that it will stop. It will check with the last element, and if the last element is a member of init element,
yes, sir.
then it will terminate. Otherwise, it will go to the else part here. So
Okay.
if this last is not a part of this init element, it will this member function will return false. Okay. So once this member function return false, it will go to this else block.
Okay, sir.
It will not execute this part.
Yes. Sir, I'm asking, sir, if the last member is a part of this init element, then where the pseudocode will go, sir, after that? What will it return?
Yes, then it will return all the initial elements. So, for example, say your initially, let's take the same example. What are the elements?
1, 2, 2, 4, 2.
2, 2, 4, 2. Okay. So in that case, what will happen? Here when it comes, our init is 1,
2, 2, 4.
2, 2, 4.
The 1, 2 is
Say,
missing,
okay,
sir.
that's what I meant. Okay. So this is 2. Yeah. Sorry, my handwriting is very bad.
It's fine, sir. It's
Please
you
bear.
can see.
Okay. So
Clear.
now what will happen? This member will return true, because this is a member of this this list. Okay. So
Yes.
it will go inside this block and it will execute the return statement. And then from once it sees a return statement, it will not see anything else. It will go back to the position from where it is being called. it's get called. Okay. So from some point place you must have called this function unique. Unique function you have called from some place, right? That place it will go.
Sir, this is my doubt, sir, over here. This is not returning a unique in element, sir. Then how it will call
Yes,
a
sir, there
procedure
is a
again, sir?
mistake in two because there is a no unique.
This is
Yeah,
not.
it is, of course it is yeah, we said it is not correct code because it is not checking the rest of the elements. This part, it is direct returning.
Yeah, then it stop now, sir.
It stops. So that's why it is not a correct segment
So
of code.
basically, said
See, the
basically that
first,
this code will remove that last element only.
uh,
Then it will
so
stop.
see, what is the question? It will remove the last question and last element and it
uh,
will stop.
It
But
will
if
not
it
be
is
able
not the
to call
case,
the procedure
then
again, correct?
uh,
Sir, it will not be able to call the
so
procedure. Am I right, sir?
it will not be able
Not
to.
call the procedure again, sir, because it is not returning the unique init element.
Yes.
Uh, See, if it needs to call, it needs to call before this return statement. Okay, before this return statement, if there is this statement called unique,
Yes, yes.
then this
Init else.
it's called, unique, unique, LE, else. Then it will call this procedure.
Hmm.
Okay. Now, what will happen? Okay, so both this code segment A and B is not correct.
Yes, it is wrong.
That what will happen with C? See, C again compares uh, the last element with the initial list, and then if it is true, again C. Here again also, is it the same thing everyone coming, or is it indeed the options? Okay, let's go with the options. So here again, see, they're returning. Okay, so
Yeah.
which is again wrong. Both the options are, isn't it? Seems like they're same.
Yeah, both the
What do
options
you
are
think?
same. I think. Yeah.
No, no, both options are not same, sir. So the fifth part of this option is it is returning the init element where it is returning the unique init element. The else part is calling the procedure, but the upper part is not calling the procedure.
Okay,
This
okay,
is the
okay. Okay. Yeah, here
yes.
they are different. Uh, okay, okay, fine. Thank you. Then coming to the last part, here it says if number, sorry, not number, member of init elements is last of n, then unique of elements. Okay, which is fine. If this element is already exist, then we should not include it, and we proceed with the remaining elements. And else, what it's saying again, it will called initial sorry unique procedure. Please mute yourself. I don't know who is speaking.
Arman, mic is on, sir.
Yeah, echo.
Okay, so yeah, if it is not, let's consider this example again. 1 2 2 say 4 2. What will happen now? Initially we'll see 2. Okay, so then we'll do this 1 2 2 comma 4 is our initial list, and the last is 2. Okay, so this will return true. So we'll go to the else part, and from else part, we'll call the unique with only 1 2 2, and sorry,
Oh,
uh, this is yeah, 1 2 2 4. Okay, so next time when it comes again in the same functions, it will again check with 1 2 comma 2 and 4. Sorry, 1 2 2 and 4, and this will return false. Okay, so when it return false, it will come here and it will call unique elements with. Okay, let me go here. Alright. Now our initial elements are 1, 2, 2. This is here. It will call unique with these elements. Unique, sorry. And it will plus with last of L. Okay. So this is here. So for some time, forget this. Say, just think it exists here, and from here we'll go in the same function. Now from this list again, how can we how will we split 1, 2? This is list, the initial part, and 2. With this, the function member will be called. Member function will be called, which will return true. So it will go here, and it will call this unique function again. So from here, it will call unique with 1 and 2
One.
only. 1 and 2. So I'm running out of space. So let me check if I can erase something. Can I erase this part?
Yes, sir.
Okay. But sorry, I removed erased. But we have to backtrack also, and backtrack and find what is the final result. Okay. So from here it will call 1 and 2. So 1 and 2 get called. It will again split this with 1 and 2. It will check with member, which will result false, and then so it will go to the else part, and it will call which function? Unique. Again, I'm writing G. Unique. The first is 1 plus 2. I mean, last of L, basically. So, yeah. Now, again, when it calls, when it receives here, if you see in the beginning of the code, here they're saying if the length of L is less than or equals to 1. So now there's only one element in this list. Okay, so it will return the list as it is. Okay.
Yes.
So this one, so it will come, one will come here, and with 1, this 2 will be added. So the final list will be 1, 2. Okay.
That code
And
is
then,
also there, sir.
Sorry?
Code was also stored
Code-
initially, sir.
No, it will eventually come, not now. So it
Okay,
will come here, and from where it is being called. Okay, so it is called from here. And again it will come here. So at that time, last was I think 4 here.
Yes.
Okay. So 1 to 2, that time 1 to 2 is written. So with 1, 2, and 2, it will add 4. So finally, list will be 1, 2, sorry, not 1 to 2. This
Yes.
return one, right? The return one will be added. Return one is 1 to 2.
Anandi, just mute your name.
Okay. So it will be 1, 2, 4. So then we don't have any other elements, right? 1, 2, and 4 only. Okay. So finally, we have the unique elements. That means D is a correct option.
Yes.
So here by solving this question, we also saw one special type of function called recursive functions. Okay. So recursive functions is basically function which calls itself.
Sir,
So here you
this
can see this.
regarding this, sir, recursion
Sorry,
functions are
not function. We discussed.
uh,
Let's say procedure. I mean, sorry, I said function.
procedure.
So
Sir, when it calls the return values, return unique init element, the last value we were storing, sir, is it also getting called with that function or that proceed to the procedure initially, or is it getting stored somewhere, sir?
can you come again? Initially, when you are calling for the first time, you're saying.
Sir, like we sir, return the unique init elements, right, to the procedure.
Mhm.
The last element that we are adding the list that the last element is what is happening to that list, sir? Is it getting called? It is also like getting called with the this procedure, getting called to the procedure.
No,
Where
no,
are
no,
we?
no, 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 not. It is not getting called to the procedure. See, always the procedure calls is happening with this parenthesis. Okay, this parenthesis you can see here. This parenthesis opening, this parenthesis closing. So this is especially for function calls. Okay, so this part is function call only. This part is not function call. So
Okay.
whenever this function will be called. Okay, so and in that called function, something will happen. As of now, this is a special function which call itself, but you consider that if it is a different function, then in some other space, some operation will perform. Say some addition of the elements in the list, and say this addition is, total sum is 100. This 100 will be returned here. Okay, the value whatever they return, they can return one single number. They can return string. They can return list. They can return dictionary. They can return anything. Okay.
Okay.
That value will be replaced here. Okay. So in our case, this unique returns a list. This list will have some element. Okay.
Okay.
This,
Okay.
so with this list, so when this function calls and get backs the result, that time this function call will be replaced with this list only, list or whatever the return value is.
Yes, I
Okay,
got it.
then it is no more a function call. It is addition of two lists. Last of.
So can you show the questions? Question of 1 number question. This question.
Yes. Can you see
Okay,
now?
okay. Yeah, got it. I just as I confused in that item list that it's take the initial L. Okay, okay, sir.
Mhm. Okay. So yeah, I hope it is clear. Let's go to the next question. Next question. My audio is okay, right? I mean, I can show some notification here. That,
Yeah,
audio
all is
not
okay.
good. Okay. So
Yes,
this
sir.
is the next question. So this is the next question where it asked, a word is said to be palindrome if the word is obtained by reversing. It is the same as the original. Obtained by reversing, it is the same. Okay, wording is difficult, but palindrome is, if you see from the left side or right side, it will be same. Okay, or in other word, if you reverse the reverses string or word, it will be same as the original one. Okay, so that they're saying. For example, madam is a palindrome. Let X be a row in the word table. At the end of the following pseudocode, flag stores true if the word X is a palindrome and false otherwise. Select the correct implementation of the procedure is palindrome. It is a multiple choice question. Okay. So what they're doing, they are saying word list is a empty list in the beginning, and flag is false, the initialized. Okay, fine. Next, what they are saying, word list is explore x dot word. Okay, so consider x is given to you, some row of this table. Okay, and you explode it. So if we apply explode function, it will give you return you what? Can you anyone tell me
List of
what
words
explode?
separated by comma.
No, it's
Letters in the word
No, yes, list of letters in the word. Okay,
separated by comma.
so uh, then they are calling one function where they are saving flag is equal to is palindrome word. So here, this is a nice example. Someone asked a question how this function works. So here you can see this flag is a here flag is false, right? So it you can think that here also this flag will be a binary some value only. Okay, so it will be either true or false. But in right hand side you see a function call. You can think how can I save a function call to a binary variable, right? But it is actually in the right hand side. This is a function, but when this function executes its all statements and returns some value, this value will be replaced in flag variable. Okay, so you
Yes.
see in the right hand side whatever value you got, that will be replaced in flag. Okay, fine. So what we'll do, we have to implement this is palindrome procedure. Okay. Mhm. Let's see what it's saying. So palindrome definition you got it.
Yes, sir.
You know, right? So first is procedure is palindrome receiving list L. Fine. If L is less than equals to 1, then it is returning true. Okay, so if you don't have any element or only one element, one letter in this list, then it's already palindrome. They say so, which is actually I mean for zero element you can argue, but I think it's fine. I mean for one element there is no confusion. It's a palindrome, but for zero element you just can. I mean, you can consider this. Considering this, you can write this code.
And
Yes.
sir, I mean, this will work if the number of letters are even or odd. In that case, we will get either 1 or 0.
Let's see the remaining part of this pseudo code. But looking at just for the first line, we cannot say this. I mean, Ari, did you complete this pseudo code and then you're saying or what?
No, sir, I have not watched this.
Okay.
Sir,
Okay.
I have a
Uh,
doubt in the line 2. Why they are mentioning that length of L is less than equals to 1? They are instead of the equal to 1 because there is always a one word is left.
I mean, it may be empty. So see, in your word data set, every word consists more than I think 3 4 letters.
Yeah,
Okay,
sir, like
but
I. If
your
you talking, if I'm talking about the I, then the last element and the last and the first element is same. Then Y is left, so the length will be always one. Now, in that case, there is no case that there is
of
a
course,
odd
of
number of
course,
letters.
no odd even is a different thing. Okay, odd even is a different thing. What I'm coming to your first doubt is that you are saying there will be at least one element.
Yeah.
That's your first doubt, right? So I'm saying whenever you are writing any code, your code should be generic, okay, which should be applicable for any kind of input, any kind of. For example, say if you remember from the lectures, professor taught this factorial question. Okay, so there he said someone can give you -5. So how will you find the factorial for that? Isn't it? Which
Yeah.
is I mean, for a lay person, you will say tell that okay, why are you trying to find a factorial for a negative number, which doesn't make sense. But
Yeah.
the user maybe they are not so smart and they are so dumb that they are trying to find a factorial for -5. Okay, so same way here also. maybe the one who is using your function, you implemented the function for someone. See, whatever you do, you are not doing for yourself. I mean,
Yes,
you
sir.
will in future you will work in some company. That company will have some clients. So client may think, okay, uh, uh, just try with empty
Right, sir. There is a no
list.
issue using that less than one. So that is the case.
Sorry.
So, so that means that there is a, if I use that less than one, so there is no issue now. Then that will.
Who is this guy making noise? Everyone, please noise yourself. Why not? We are not listening. Please mute yourself while
सब
you are not
बना के
talking.
देंगे आप पीछे पड़े चाहे ना पड़े
Yes, sir. Mass Siddiqui.
Who is this guy? This
Mass Siddiqui.
Mass. Suya.
Mahas, please. Can you hear me? Okay.
Yes, sir. Continue, sir. Explain.
So it's very
Sir,
annoying.
I want to say that in line 2, if I use that less than sign, that there is a no issue with it. Every word that it is a palindrome, it's will work for that line 2. That's mean.
Less
No,
than.
no.
So if
Sir,
you
you
use
explain.
if you use so if you use less than, then
Yeah.
is it possible that your list will have length of your list is uh,
Sir, I want to say
uh,
less than or equal to
list?
together.
That's fine. That's fine.
Okay, sir. If I use that,
That's
if I
fine.
remove that less than sign and also
Let
only use that equal to sign, then that is the case. It also work now. It will also work in that case.
that in that case it will work, but you have to mention that you should not use
Yeah, all of the
a
possible
list which
cases.
has
If
both.
there is a no issue to use that less than
uh,
sign, then I can use that also.
yeah.
Okay,
So
sir.
you just have to mention whoever using, you have to tell them, okay, please don't use this. Okay, there's one more thing you can do. I mean, for your future, I'm saying. So in those situations, what you can do if uh, someone is asking with invalid input, okay, so someone wants to process with invalid input, you can just show a message. So sometimes you may see whenever you are trying to access something in internet, you see some error message. Okay, so they are not just blindly uh, blacking the web page. They're telling you something that you did this thing wrong. So please correct it and try. For many times when filling the password in online, you may observe that when you give a wrong password, they show a message with a red color text that this password is wrong. So it's not like they are just checking and there is no match, so they are silent. These things you can do. Okay, yeah, let's go with the remaining code. So the first line is just this is taking care of the edge cases, and then they're saying if first not equals to last, that means what it's called.
Yes, sir. The code is
Say,
right. Option
uh,
A.
say we have say what is called. Let's consider madam only. Okay, let's
Sir,
consider
you can
this
take I.
is
So it is short.
then it will return from here only.
Yeah.
So if I take I, it will
By
return
one
from here
step
only.
you can do.
Here it will come for the in one step only. You will see it will see the length is 1, less than
Yeah.
equals to 1, and
And
it
the
will
return
return
is true.
true. It will return true. So it will go here, and this our flag will be true. Okay, but in case we have large this thing, let me erase this and try to write. Okay, consider this input is given. So what will check? It will come in this procedure first, and it will check, okay, length is not less than equals to 1. It will go to the next step, and in next step it will check, it will take the first and last. Okay, first is M, the last is also M. not equals to, if we apply not equals to, this will result false. Okay. So if it is false, it will come to the else part and it will call again. So it will return. Okay. See, here it is returning, but inside, when it comes inside return, it sees a function call. Okay. So which is palindrome, again calling the same function. And here
Yeah,
what
it's
they're doing,
basically remove the first and last element and
okay.
return to
So
the
it is from inside
palindrome.
C rest. So rest is what? This part. Okay. So A, B, A, M, add on. Okay. Then they are applying init. So init is the first part, this part. So A, B, A. Okay. So with this string, this list, the same function will be called. This is palindrome. So it will go here again, execute the same set of steps, where again it says length is not less than 1, and it will come here again. First and last element when are same, so it will come to the else part, and from here it will call with b only, and finally it will return. From here it will return true. So from here, when it returns true, this true will be returned here. Okay, for the first function call. Again, we called this from two times. This return is palindrome twice from this place. Okay, so first true will come here, then this true again will come. Uh, I mean, I'm not writing the entire steps. You can like imagine how we reach here. Again true, and from here again it returns true, which true will be returned here. Okay, any confusion?
Sir, what is that returning in the last step, sir? After it got true?
But if so, this true will be written here.
Okay.
Okay, and I'm saying what I'm saying. This is palindrome function. We call twice from this same place. Okay, so first time for ADM and next time for D. Okay, that's why
Okay.
it will return true here. I mean, it's not exactly returning here. What happening actually is like you will maybe if you have C or any other um, programming concept, there you will. I mean, usually it should be taught here only. So basically, what happens for every function calls, you create something called stack. Okay, in stack you create a function call with is palindrome. I'll write it IP. Okay, for some time to make it simple. So it will call with MADAM.
Last in, first out.
Okay, initially. Yes. So yeah, next time it will call with what value? ADA. Okay. So IP will be called with ADA. Then next time again IP will call with what? D only. And finally it will return from here. It will check the length, and so here you can see it will check the length, and since it is 1, it will return true. Okay. This true will be returned here. Here. Okay. This true will return here. And since now this is true, this true will again return here. They will return here. And finally, from here, it will return to the place from where it get called. Okay. Now is it clear?
Little bit, sir. Sorry, I was so today only I was trying this code, but got stuck like what to do, where to go. Now it is little bit
Okay.
clear.
So yeah, this way you can try. I mean, it's more convenient to actually understand what is happening.
This
Okay.
is also
So
recursion, right, sir?
yeah, yes, it is also recursion.
Okay.
Sir, I have a doubt related to DFS. In the
Mm.
when we forming a tree from the DFS graph, from a graph,
Mhm.
like we are using the stake last in first out. So usually we don't use that process how the stake will working, and we just thoroughly draw the tree. Like we need to know that how the stake will work for that case. step by step.
Okay, so how it works is that so again you can think of this type. So when DFS calls now,
Yeah.
DFS will call with some value, say with X. Okay, and is this X has some neighbors, say Y and Z. Okay, so for BFS, what you do, you write for each neighbor,
Yes, sir.
neighbors,
Adjacency list.
neighbors. You you just update this visited of each, say k. You update visited k is equal to true. Okay, you
Yes,
in
sir.
a sequential in this inside this loop. But
Sir,
for
I can also use the
DFS,
0 and
these
1
are
index instead of true or
0 and
false.
1 index.
Like that is
No,
not visited
that
by
is, you
0.
should not say
I can
index.
represent that by 0, and that which nodes are already visited, that I can represent by 1.
So yeah, so this is your convenient. You can choose.
Yeah.
So this is for BFS. I said okay. Someone asked what we're discussing. We are discussing BFS and DFS. Okay. So this is what happens in BFS. But in DFS, this is again inside loop. This is not updating. This is calling the DFS again from here. DFS with this, if the node is not visited, this is calling this k. Okay, so when it calls, this first x will come here, and again with k will come here. Okay, so in this sense, this with function call it is using stack.
Okay.
Now clear?
Yes, sir. Yes, sir. Okay. So that means, sir, in the recursion, we are using the stack, no?
Recursion, yeah, always see. For I said for every function call, the system uses stack.
Yeah.
It is not necessary for recursion. If it is a normal
Recursion
function call
only.
also,
Then
it will
there
use
is an
stack.
other process too that uses the stack to call the procedure.
Huh?
Yeah. Okay, sir.
Yes,
Thank you.
yes. Okay. Okay. So the next option is procedure is palindrome. Okay, again, the option. So the first one is correct, right?
Yes, sir. I am just confused about this one, two,
Yeah. Okay. So in
two,
second,
step
they are
two.
saying equals to one. So equals to one is also fine, but it is not exactly addressing the edge case, isn't it? So someone may pass empty list. So that time it will fail.
Sir, in that
Okay,
case, I
yeah,
want
cool.
to say that if there is an palindrome with the even number of letters, in that case, it will not work.
Even number of words. Why it will
Yeah,
not
it is
work?
not
Let's
possible,
see
no, sir.
why it will
Like
not work.
that. I'm just
That's fine. Yeah. In this case, it will not work because they'll not know situation when one
yeah, it
element
will
will
be
be there.
zero. Length will be
Either two
zero
element
in
or
that
zero
case.
will be there. Uh, uh, so it will be
But
either
sir, there is
even
any
or
word
because
exist,
we are.
palindrome exist with that even number of letters?
Yeah, of course. I mean, see, palindrome is a concept only. You can make any word. I mean, this is a palindrome.
Okay, that means
It is not
it's
necessary.
not
It should make
it's not
sense.
necessary to necessary that there is a meaning of that word.
Yes, yes. So
Okay,
say
okay,
for
sir. Okay.
numbers, you can say 1, 2, 1, 2, 3, 2, 1. This is a palindrome.
Yeah.
This is a number only. Okay.
Sir, that means 1 1 is
Okay.
also a
So
palindrome because the last element and the first element is same. In that case, it will the B code
one
is not working. So that in that case, so you need to mention that less than equal to term.
yes. So that's why it is not correct.
Okay, okay,
So
sir. Okay,
the
sir.
question
It's
is
clear now.
asked like which are the correct option to choose which are correct pseudocodes.
Yeah.
Okay. So if then they are checking if first equals to last, then they are calling is palindrome init rest. Okay, so if the two extreme end are same, then they are removing these two elements. So as of now, I hope you understood what this init and rest is doing. So it is just removing two extreme elements
First and last element.
from the first and last. Yes. So it seems correct, and if it is not the case, if they are not same, it is returning false. It seems correct, but since it is not considering the edge case, that's why this is not a correct candidate.
So in this
Okay.
pseudocode, the only problem is there in the step 2.
Yes, yes.
Okay, sir.
So in the next code, again, they are taking
So
care of
it's
this
correct.
edge case. So
Because in
let's
the
see the
step
code.
number 2, they are mentioning that less than equal to 1.
Yeah. Let us check. Let us check. Then it's checking if first of L and last of L same, then is palindrome same. Yeah, of course. So both the above code and this code is same. Only thing is it's taking care of the edge case. So it seems the C is also correct, but let me again confirm. So if length is less than equals to 1, return true. If first and last equals to same, then is palindrome with the remaining element. Otherwise false. Okay, fine. It seems correct.
Sir,
Then
am I audible?
yes,
I mean, I
yes.
had a doubt in this line number 6. I mean, this return
Line number
is
6.
palindrome. Yeah, sir.
Okay. What is your doubt?
I mean, I'm not getting
Clearly.
this. Like after this 5, I'm not getting the code.
Okay. So what will happen? Initially, say let's again take the same word, madam.
Right.
Okay. Fine. What will happen
Okay.
when we call the first time? Let's divide here. When we call for the first time, this L will have this list. Okay. L is
Yes, sir.
madam now. So it will check the length, which is not less than equals to 1. So it will come here and it will check the the two extreme element, first and last. Okay.
Right.
First, you see
Right.
first of L and last of L. It is checking if they are equal. They are same. They are equal. You
Yes, sir.
got me?
Yes, sir.
So if you are convinced here, then what will happen? It is doing. It is returning. So it will return something. Okay, let's see what is that something. So it will go and return what is called is palindrome. Again, what a bad luck. It's calling same function. So I mean bad luck in sense we have to perform the same something we have to do. So where is is procedure? Is procedure is this function only. Okay, so it will call same
Right.
function. But what parameter it is passing? It is passing init of something something blah blah blah. So whenever you face this situation, you please go from the center. Okay, from center what is it
Okay.
doing? Rest of L. Rest of L is what? Can you tell
ADAL.
me rest is what?
Like we'll be
AD.
removing the first element.
Okay, ADAM. And then
Yes,
init
sir.
will be this part.
Initial.
Okay.
Oh, okay.
So
Oh, got
here,
it, sir. Got it.
so again, okay, yeah, that's it.
Yes, sir. Got it.
Okay. So next, let's check the last one. Procedure is palindrome L. Again, receiving. This seems fine. This till here, doing same thing. Then they're checking if the first and last is same, then they are returning true. Otherwise, they are calling is palindrome. Can anyone tell me what is the wrong here? What is wrong here? Can anyone tell me? Is
So
there
in
anything
the
wrong?
second statement, if it like let's suppose if we took the example MCDAN, so even though the first and last letter are the same, but the middle letters are CDA, and that does not form a palindrome.
Exactly. So they are just checking the first element and last element.
So
They are
it's not
not
getting update.
taking care of the remaining.
The other elements we can't check.
Uh,
Like last element and the first element we can check only.
Yes, yes. So yeah, that is the reason why it is not correct. So answer is A and C. Okay. So the next question is 3. Oh, so many questions you are remaining. Next question
Sir,
is
can you
again
move to the
considering the
graded
following.
assignment question? Sir, it's easy. So this
Uh,
question 3 to 7 is easy.
okay, let's take the opinion from others also.
Okay,
What
sir.
others
Okay.
is? I mean, I can give you some time, like after 8. Others, what you say? Should we skip or?
Sir, I think we should discuss this 3 to 7 first, and then we should go for the graded.
Okay, sir. Then can you
Okay.
then
I mean, there
I
are issues actually.
Uh,
I can wait, sir. I can wait.
uh, okay. So what it's saying, considering the following pseudocode, assume that A and B are two positive integers. Okay, fine. Then given this procedure, calculate. It's doing some calculation. It's finding a difference of 0, and sorry, it's assigning difference is equal to 0. Then if A is less than B, then it returns calculate B comma 0. And if the A is greater than B or equals to B, then it is coming here, and again here checking if A and B are same, then returning B. If it is not the case, that means B is smaller than A. Then they are again calculating one difference here, and then this difference, if the difference is less than again B, then calculating some, then returning calculate difference of difference comma B. Or else they are returning calculate comma B comma difference. Sorry, I told that. Okay. Yeah. So actually, this is some standard algorithm to find GCD, greatest common divisor. Uh, if you remember, I don't remember the algorithm name, but this is actually a very efficient algorithm to uh, find the GCD. So let's see what is the question. What is the return value of calculate 12 and 3? Okay. So step by step we can go here. For 12 and 3, this initially A is equal to 12 and B is equal to 3. Okay. So first difference is 0, A less than B or not. A is not less than B. So we'll not go here. And then if A is not equals to B also, so we'll find the difference. Difference is A minus B, which is how much? 12 minus 3, 9. Okay. So 9 here, if you check, if difference, I mean, as I said, this is GCD. You can directly answer the question. When if you remember the algorithm, you can answer directly the question, but still let's calculate. So difference is 9, where difference is greater than B. So uh, we'll execute this statement. Okay, calculate difference. So let's here calculate with 9 and 3. Okay, so second time we are executing. Now A is 9, B is 3. Okay, again A is greater than B, so we can directly come and calculate. 9 minus 3 is again 6. And since again this difference is greater than B, we'll call again calculate 6 comma 3. Okay, and then we call again this third times. I think these steps are. Yes, I'm speaking. Am I not audible?
Yes,
Yes,
Hello?
sir, you're audible.
Sir, you are not.
I was muted for how long?
You're not muted, so you're audible.
Sir, you were clearly audible.
Okay. Oh, fine. So, someone, I think, not muted himself. His mic is on. So I can hear myself. Oh, okay. Sorry. It's my fault. I joined with two devices actually. So, so I think this process is more convenient. You can see how many calls are there and everything. We now our A is 6 and B is 3. Again, A is greater than B, so we'll find the difference is equal to 6 minus 3 is equal to 3. And now we'll call difference is not greater than B, so we'll call this execute this statement. Okay, so which is again return calculate 3 comma 3. Okay, so fourth time we are calling. So fourth time what will happen? A is not equals to B, A is equal to B, so we'll return B only. So
the answer is
for A
3.
equal to
Return to B.
yes. So B will be returned. Okay. Fine. That means answer is 3. See, yes.
Yes, sir.
Okay. So the next question, fourth question is what is the return value of calculate 4 and 17? Okay, I'll recommend you to try your own.
Yes, sir.
So
We
you
can
know
do
how
this.
to
Yes.
do it now.
Got it.
So same process. Now, I mean, the expected answer should be 1 here because it's calculating the GCD, right?
Sir, is calculating GCD or HCF? That are different, HCF and GCD?
Same thing.
Same.
Same thing. Okay. So the fifth question is how many times the procedure calculate got called in order to compute
I think 9
calculate 14.
times.
Okay. So that yeah that if you solve we can if you solve the previous question this is just one question only. Next, the sixth question. Should I solve the previous question, everyone?
No,
No, sir, it's easy, sir. You solve
Okay.
that
I
already.
mean, I'm asking others because, see, maybe easy for you, but maybe difficult for someone else. Okay.
Okay.
This question is for any two positive integer a and b, what does calculate a comma b returns?
HCF.
Yeah, highest common factor.
The two
Something.
numbers.
So if we solve, you can easily go to. Then seventh question is, what is the result of following expression? Assume a and b are two positive integers. Calculate a comma b and calculate b comma a. Of course, see, the GCD for a comma b and b comma a will be same. So it should be true.
Yeah.
Anyone not convinced?
Sir, one simple doubt for question number 6, sir. Just need your insight
Yes.
on. Sir, regarding the option D, sir, like for this condition also we get the answer, right? It returns the SCF of two number provided A is greater than B. In the question number 4, we had 12,3 and we got the answer 3.
But it's
Ah,
not
yeah.
necessary that A is need to be greater than B.
See, yes. I mean, if you are saying okay, my A is greater than B, it should return. But this algorithm, by design, do not require A should be greater than B.
Okay.
That's
Yeah,
it.
in the if you solve that 7th number question, then your doubt will clear.
So here, see, it says it returns the HCF of the two numbers provided A greater than B. What does it mean? It means that if your A less than B, then it will not return HCF, which is not correct, right?
Yes.
And
Got
you can see you can see this in a like other way if you convert it. Okay.
When the pseudocode is to return for all the conditions, should be true.
Yes, yes. So if you see if your A is less than B, automatically it will be converted to its own
Yes, a
format,
greater
because
than.
see here it's checking who is greater than less than, and based on
Yes, sir.
this it's changing.
Got it, sir.
This is actually very nice algorithm, and it is for many time it's being used in I think cryptography, if you remember. So yeah, I'm going again um, out of the track and taking something else. Like when whatever communication we do, they are encrypted, right? So if you're sending any message to your friend in WhatsApp or any social media app or anywhere, it's actually going in a encrypted format, and the other side, he'll know something from using which he will decrypt. He will be able to know what you sent. In middle, it's I mean theoretically possible, but practically it is very difficult to decrypt.
Okay, this is the usefulness of that code.
I mean, this is used for that purpose only, to find GCD. Many times we need GCD. So exactly, if I tell you where exactly it used is, it used in something called key exchange. So say for example, you have a key for some lock, right? Your friend is also having a lock, but I mean, you initially your friend don't have this lock, so you have to give this. I mean, what I said, sorry. You have a lock. For that lock, you have the key, but your friend don't have the key. You somehow, in some way, you want to share this key with your friend. At that time, say you cannot meet him also. So how can you share? So to solve this problem, some of great scientists, they solved that. If you use initially, you choose any random two numbers, you and your friend, they will choose any random number. Then people will calculate GCD based on some other numbers. You will exchange. Eventually, you both will converge, and you both will have some number which others cannot predict. Of course, if at the beginning only, on behalf of your friend, someone else is pretending and he is responding to your message, he'll be able to know. But otherwise, it is very difficult. But just looking at the conversation, what is happening, like what is the ultimate key? Okay. Sorry to interrupt. Yeah. This is sixth question. I think this is the last question, right? Or there's another question? Okay, one more question. Yeah, seventh question is also we solved. Seventh question, anyone having doubt?
No, sir.
So now we should go to practice assignment.
The graded assignment.
Yeah, again assignment. Practice assignment. Hmm? Which question?
Sir, can you go down? I don't remember the number of the question.
Better
This
if
question.
you can share your screen. You share your screen so that you can show the
Yes,
exact.
sir. The question number 2.
Okay.
Sir, my doubt is like that. For after reading this question, I naturally I don't see the code, and I just imagine that there is a.
Sorry, there is a. Hello, I think you're on mute.
Yes, sir. Yes, sir. Sir, I want to say that uh, how the code will work. I want to know because I just confused
Okay, let's
in that code.
mm, let's read the question. An auto grading system for an online course is designed for the following way. A student submitted is recorded as a dictionary, so dictionary with the following keys. The roll number key roll key maps to student's roll number. The time
No.
key maps to the time of submission. The score key maps to student's score for the submission. Okay, fine. These are some key verifiers. Um, okay, then each student can make multiple submission before the deadline. Every time a student makes a submission, the dictionary corresponding to the wait, where it is. Every time student makes a submission, the dictionary corresponding to the correction is appended to the end of list called scores. An example is scores is roll number time scores
Yeah, ascending number of ascending order
no,
of time.
yeah, yeah, of course, it will be ascending order of time because it's just
But sir,
adding at the end, right? But
if I reverse the order, then it will be descending order at time.
uh,
Then the code will that code will that the value from the code that value we are getting that is the first time of the submission for that roll number.
no, if you reverse it, then it
Yeah.
will be the last time of the submission. First,
No, sir, I
first
don't think so
dictionary.
because the answer is basically the last submission. Okay, then if I reverse that order in the there is a ascending order of time. If I uh, show the fix the list in the descending order time, then it will
uh,
have the value of the
will
first
be
submission. No, in that case.
no, no. Then your first entry will be the last submission. I mean, so if you let me come
Yes, sir. Please go through this
can
code,
you
sir.
see
I am
the
just
highlighted
confused.
part?
Many of the questions.
Uh,
I have
can,
so much question in
can
that
you see
code.
the highlighted part?
Yeah, yeah.
Can you see the highlight part? So
Yes,
if
sir.
you sort, your last entry will come here.
Yeah.
Uh, based on time. Okay, if you sort. So
Yes, sir.
so
Based that
then this
basically
entry
I
will
want
be
to say,
go ahead.
okay, sir, because there is a ascending order time. Now I am if I am like the roll number 12, that 11:50 time, if that time like how can I say?
Okay, they said one student can make multiple submission, right? But here,
Yeah, yeah.
this roll number, if you see,
Because
yeah, there
what
is
the sir
repeated.
in the list,
Okay.
the order is important and the scores is the list basically. So in that case, if I last submission in the first element of the list, then uh, then it stores the
So
first submission, no? In that case.
yes, yes, yeah. In that
Yes.
case, it stores your
Yeah, yeah.
first
I
submission.
just want to ask you
But what
this thing.
but what you said next is that you want to sort them in reverse order.
Yeah, yeah, yeah.
So if you sort them in reverse order based on the time only,
Yeah.
then this last entry will go in the first place.
Yes, sir.
Sir, you better, sir. Sir, can you please run this on the pseudocode, sir?
Yes, sir.
It will
Yes,
be
sir. It will be better, sir.
Okay, okay. So okay, let me read the pseudocode first. Study the following pseudocode. Procedure is present L comma roll number for each D in L. If D of roll number is equal to roll number, returns true. Okay, they're simply checking if you are present or not. Okay, so what happens? Say
The
we
second
have
code
this
is
dictionary.
necessary to do.
Hmm?
The second code is
Sorry.
important. I think that there is no use of first code. There is, I think.
Okay, what is the question actually? First, they study the following pseudo code. This is the one pseudo code. Again, there is another pseudo code. Also, I think let me check if this is present is getting called from get subs. How they are related? First sub, get subs. Okay, yeah, this procedure is getting called from here. So that's why. Okay, so this first part is only checking if you are present or not.
Yeah, yeah.
Okay, so then in the next part, procedure get subs is doing something. So let's see first sub in means maybe first submission is an empty string, then rest sub is a list. Okay, so if length of L is less than equals to 1, return L. Okay, basically they are taking care of the edge cases. So I hope by now you know the necessity of this code block.
Yes, sir.
Okay. So next, what is doing? First sub is first of n means from the list it is abstracting the first item. So first item will be again a dictionary. Remember. Okay. So yeah, everyone conveys right. Like the first item will be a dictionary. Anyone
First
have any doubt?
subject.
Yeah, this
Yes,
first
sir. I
from the
have the
list L will be a dictionary.
yeah, sir. Roll number 12 time and 1020 score 89. Yes, this is the dictionary basically.
Uh, Dictionary. So rest sub is again they are just removing
It
the
is a
first
list
element and rest of things will come. Yeah, this is a list.
of the
Okay.
dictionary.
So if is present in rest sub, first sub of roll number. So see from they're checking if this roll number is present in the remaining list. Okay, so eventually what will happen? I mean, I cannot write the whole this thing because this is a huge list, right? So you can
Sir,
think first this one will be removed. First element will be removed. So we'll be end up with this 4 last 4 elements. These elements. Okay. In first step, you will be having this is separately, and in list you will have rest. You have this 4 element. So if you check in 4 element, they are just checking if it is present. Is present using is present function, which is true, which will return true because see this 12 is exist here, so which will return true. Okay,
sir, in the line 8, the first subject roll represent that 10 and 12 like that.
no, it represents 12 only. It is 12 first in the first step.
No, sir, I just ask you that what is represent? It is representing the roll number actually.
Yes, roll number. So
Okay, sir.
value of this roll number, so 12 maybe
Yeah.
12, sometime it will be 20, sometime it will be again 12, sometime again
Okay.
12, this thing. Okay, so it is checking if this roll number is exist in this list. Okay, so then you go to is present procedure. In is procedure, is present procedure. What is checking? It is taking a list and roll number, and for each dictionary in
E
this
is there.
list, it is checking if this dictionary of roll number is equal to same, like if it is same or not. I mean, it's basically checking the roll number is exist or not. Okay, so if it exists, it will return true. And for the first time, it is indeed true. So what you'll do, return get subs of rest subs. That means just removing the first entry. So eventually what it is doing, so okay, let me just check. Otherwise, what is doing, first sub plus get subs. Okay.
Sir, you can
So eventually what is,
number 8 step, please. Can you explain the 8 step again?
This
Is
is a
present.
recursive procedure, right?
sorry?
Is this a recursive procedure?
Yes.
Yes. Here you see get subs is getting called. So it's
Hmm.
recursive. So basically, what they're doing, you have a list of
Sir, can you
dictionaries
write that?
where
Basically, I
each
am just
dictionary.
confused in the line number 8.
Okay, let me just give overview of this question.
Yeah.
So what is happening? You have a long list where each element is a dictionary, and each dictionary is representing like your roll number and when you submitted and other things, other information. So from this list, you just need this get subs is only removing the duplicate entries and keeping the entry which is your last submission entry for your last submission. Okay. So line number 8 you're saying. Okay. So line number
Yes, sir.
8 is what? Your rest sub is what? Your rest sub will be, if you see here, consider
Basically,
this
the
example.
first element, except the
Uh,
first element, all the elements of list.
no. Your last four uh, elements. See, rest is removing first element and giving you all the remaining list.
Yeah, all the elements of L except the first.
Yes.
All the
So your
elements of the
rest,
dictionary, I think. Uh,
no,
Leaving
not
the
dictionary.
first
It is
list.
a list of the dictionary.
Achha, yeah, sorry.
So elements will be dictionary. Okay. So your rest, you now you know what is this rest sub. Okay. And what is your first sub? First
Sir,
sub
can
is the
your voice is not clear, sir. S- No, no, sir, no.
Your voice is not coming.
still not coming.
Sir, now it's okay.
No, it's coming.
Okay. So what I'm saying is that your rest sub is a list of dictionaries,
Yes,
correct?
yes.
And your first sub is a dictionary.
Sir, Persef
You're
is a
convinced?
dictionary. Yes. It's also a dictionary.
It's a dictionary. First one is a list and second one is a dictionary. So rest sub, what I'm saying, a rest sub is a list and
Yeah.
first sub is a dictionary.
Yes, sir.
So if you ask first sub of role for
Yeah.
this particular example,
Yeah,
this first sub of
its value
role
is 12.
will give you its value is 12. So you'll get you'll call this is present function with this list and a value 12.
Yes.
Okay.
Yeah.
Now let's go to is present function. If I come to is present function, it is taking one list, some list, and some number, roll number. Okay. And
Okay.
it is running for each D in L. So we know we can use for each loop for in case of lists. So it is taking each
Element of
item
D and
from
L.
this list.
So, sir, my question
So
is that what is the element of L? Basically, they are the roll numbers that 10 and 12 only.
element of L. No. One element of L is one entire dictionary.
Okay. Okay, sir.
That's why you see here D of roll. Again, for D is for first iteration, it will be this entire dictionary. So in this dictionary, how can you get this 20 value? If say this is equals to D. So D of roll in double quotations.
So
Isn't it?
basically, sir, the this first submission roll number is that there the roll number is acting as a key for the dictionary, and then we are in this code we are checking that whether the roll number is present in the list or not, right?
No, keys here, both
Is
roll
the
number,
value.
time, and score all are key. Okay. So for each key, there is associated value for roll number, for time, for score also. I mean, I don't know who asked this question, but can you come again? Like, what is your exactly what is doubt?
So
Or you
my
say,
doubt is the line 8, how can I proceed that first pseudocode? That is my doubt. And I have also a doubt
yeah,
in
that
I think the fourth question I have a doubt.
Okay, so
And
I
it is the
explained you,
and
no,
the fourth
exactly
question
how.
is related to that pseudocode. So I ask you this question.
Yeah, see, now I explained you. Now I explained you like what is rest sub, what is first sub, how it is
Okay.
like I cannot write it here because the length. Okay, let me go with the small number. What I can do is
So just one question,
can I
sir.
download this also?
Yes, sir, you can say.
Can I write here? Let me try to write here. I cannot write here. Okay, I'll open
Sir,
the
on
switch
Chrome,
again.
this feature is not allowed, sir.
Sorry.
Sir, on Chrome, this is not allowed, sir. You
Okay,
can
let
copy
me
the
open.
link and you can open it on Microsoft Edge.
Yeah, then it should be downloaded here, right? Where is graded assignment? Okay, let me copy this. Where is part? Oh, that is good.
Now it is open, sir.
I think I didn't download it. Let's see. Now it will come here. And here I can open it. Okay, so I'll not consider this long dictionary. Indeed, what I can do, select.
Sir, you can consider only the roll number and the time.
Okay, fine. So say I'll consider R only. Um,
Yes, sir.
Here say again I will not use this string notation. R is equal to say 12 and time t is equal to 10 something. Okay. Next is R is equal to 20 and t is equal to say 11. Next R is equal to 12, t is equal to 20 and R is equal to 12 again, t is equal to 23. Finally, R is equal to 20 and t is equal to 23. Let's consider this question. Now what will happen in line number 8 when we come by line number 8? Okay, let's go from line number 6. First of L will be your dictionary listing. R is equal to 12. I mean, usual notations are colon, but I'm using equals to. So please the way will go. R is equal to and P is equal to 10. Okay. This is your first sub. Okay.
Yes, sir.
You're fine. And the rest
Yes,
sub
sir.
will be this part.
Yeah.
This part.
List of the
For this one.
dictionary.
Okay. So now here you'll call is present. So you'll go to is present, and is present is taking L is equal to this entire list, and roll number is equal to what? Your 12. Okay. So
Okay.
here you'll have L and roll number is equal to say roll is equal to 12. Okay. So inside this, what we'll do, you check for when you ask for each D in L. So first time your D will be
Dictionary.
this one. R is equal to 20, comma, T is equal to 11. Okay. So then inside this for loop, what it's checking, if D of D of roll. D of roll is what? 20. Is equal to what roll number we got? Received 12, which is not. Okay. So
Yeah.
it will not do anything. It will go here. It will take the next row, which is
Yeah.
R is equal to how much? Can you tell me? It is 12 now.
It is not 12.
Okay. It is 12 and it is equal to 20, I guess. Okay. Now we'll ask D of roll number will be your 12 again. Right. Now D of roll number is 12.
Okay, sir.
Do you
Now I
convince?
understand.
Now I
So if you
understand.
check, it is same. So we'll return true.
Okay, sir.
So this D of roll number, this roll is working as a key, and for each key we are checking the value that whether it is the value is equals to the roll number we have on the
Yes,
right
yes,
side
yes,
or not.
exactly.
Okay, got it, sir.
Yes.
This part is more clear, sir. The down part you explained it was. Thank you, sir.
Okay.
Sir,
Okay.
I have a
So
doubt in
it's already at
fourth number question, sir.
okay. Let's go.
How can I
This one.
reverse the process?
Which of the following statement returns the list of first submission made by state? Okay.
Sir, I have just
What
one
is
more
the
question.
question?
What
Let's
is the get
first
subject procedure represents here?
get subs.
Score
Get subs
representing
give you.
the roll number and the recent
No,
last submission.
I think it should give the scores
no.
only.
It's no. Get subs. See, get subs is the same function we solved now.
Yes,
Is
sir.
the same
Yes, sir.
function.
The second pseudocode.
Then then it will return. Let me check. Source return first sub plus get subs. Okay,
The
it
last
returns
submission
you this
of that roll number.
last submission of so eventually we will get what see here
Score, time,
we'll
and
get
roll number.
roll is equal to roll colon 12 time
Yeah.
is equal to something comma something this list again the next the all the unique elements I mean the last submission detail
Yes, sir.
actually you can say
So that's why
so
asking that if I reverse
yeah
that order, then we get that first submission. Before starting the question, I asked the doubt that if you make that last element that first element and reverse the order like down to up
based on what
based on the given list.
then yeah then so then your whenever you first came across any unique rule number it will be his last submission from the top
Okay.
you're not I mean so okay let me frame what you asked you are saying you have given this list
Yes, sir.
you have given this list okay then what you're trying to do is basically you are reversing this so when you reverse this will be first position this will be in the second position this will be in third position and this will be in
Yes,
the
sir.
fourth position this row okay
Yes, sir.
so that time you will now we are looking first this second this third this fourth this and I think 5 elements are there so I wrote something wrong so now you're looking this way but when you reverse it you look this way so
Yes, sir.
first you'll see this one so that
Yes, sir.
time you can just take unique elements from this list
Basically, it takes the first submission, no? In that case, sir.
Our first submission is
no
the
no
that is made
that's
on 10, 12, 20 only,
okay
na?
okay after all the process you're saying
Yes,
yeah
yes,
you are
sir.
correct
Yes, sir.
now I got the point yes
Said
oh
that
actually
all the submission is depends on the order of the list, basically.
mhm, mhm. yeah
It will,
now I got your point yeah correct.
sir, it depends on the sir time on no, sir.
It's all depend on the
But
time.
see, in this dictionary, they already said whenever you submit, it will be added in the list. So by default, it will be in sorted order, like ascending order. I mean, so what I am trying to say is, say you first time you enter the exam, and at 10:20 you submit once. So this submit, name it, say for simplicity X. So your X will come here. Okay. And 10:45 you again submit. Say this, name this submission as Y. So Y will come here only. Y will never come before X. You got my point, right?
Yes, sir.
Uh,
So
Okay,
now
so
if
it is
you come to the
already
question
2.
4, that what is the code to write that in reverse order? That is my problem because I am unable to write that code. That is
Okay. So assume that reverse is a procedure that reverse a list. Okay, they are saying reverse is a procedure which exists. You don't need to care to write this procedure. This is given. Which of the following statement returns the list of the first submission made by the student sorted in the ascending order? So first submission they are trying. So basically, what you can do, you can first
Sir,
reverse it and then
yeah.
apply get submit subs.
Sir,
So
but
for
I
that,
have
what
a
will be
doubt in B
your
and
concern?
C that gets if the get subject get subject score, it's in the ascending order time. If you reverse that, we get the descending order time in that case. But the answer is D. Why,
Yes.
sir?
I mean, C. Okay. So C is also, like, if you see,
When
C is also
you
seems
reverse the
correct.
whole list first, you get that
Yeah,
in
and
descending order. So you have to reverse that also to get
yeah,
Yeah,
the
then it will
time
be in
in
ascending order.
ascending. Yeah.
Time will always be in
so yes,
ascending order.
There should be two
Correct.
reverse for that.
Correct.
I don't get it.
no,
You just
actually,
take that example and
that is
try
not
doing
the.
that.
I mean, that is that I'll say, yeah, that is one way correct, but there's another point of view, I'll say. So, see, in C, it seems correct, but what will return? It will return the desired result, what they asked. But what is the hidden instruction here is that, I mean, it is not
Okay, sir. Okay, sir.
mentioned
Now
here.
I get
Let
it,
me
sir.
read
Now I
the
get it.
question once.
Because the get
Uh,
subject is only representing that ascending order. Okay. No, 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 sir. No, sir. I don't get it.
Sir,
See,
I
yeah,
think,
okay.
sir.
Let me finish.
Okay,
Okay.
okay, sir.
Yeah, let me finish. Then you will say if you get it or not, everyone. So, which follows the statements written in the list of first submission made by the students sorted in the ascending order. Sorted in the order of, yeah, okay, yeah, that is correct. In the question they asked sorted order of time, ascending order. Yeah, your explanation was correct. I don't know who explained. Your explanation was correct because here it is mentioned to sort time. But one more thing I want to add here is that, I mean, it is not necessary, but how can you think here is that, say, this function is also fine. So this function, what I'm saying, yeah. So I don't know anyone is convinced or not. If this time constraint is not or given, then this function is fine. Are you agree with me?
Yes, sir, I agree with you.
Okay. So now one additional thing only, like I'm saying. So if someone, the same argument what we did for this score data set and other data set in the beginning, that if you read something from the table, you have to store back this data in the same table again in the same order. I mean, you cannot jumble it and you cannot just give. Okay, which is not a good idea. So here in the reverse, you reverse it. Again, if you apply one more reverse, your element will be in the same order. Okay. So the first part, what I'm trying to say is, say your x comes in the initial data, and your x comes first, and then y, then again x comes, say x2. This one x1, y1, x2, x3, and say y3. Okay. So if you want to give me the first uh, occurrence, you'll give me x1 and y1, right? But if you reverse it and solve it, I mean, here we numbered, that's why we know. But if you reverse it, and then you will be able to. Okay, I'm making it a bit complex.
Sir, no, the simple thing is that first we are executing the whole procedure, and then in the end we are reversing the thing, like the list or the whatever the value we are getting. Just to get
make
it in the
same
ascending
order.
order of time. We are doing that only.
Yeah, that's perfect. Yeah, that's perfect. That for that only. Yeah, you are correct. For that's why I said no. If it is not, this constraint is not given, then our
Okay, okay. In that case, yeah.
option 3 is also correct.
Yeah, in that
Okay.
case,
Anyway, let's. Okay. So
Yeah, just
yeah. So
don't
let's.
get it said anything.
Okay. Yeah. So let's stop here. It is already 8:30 today. All the best for your next exam.
the
I
best thing,
think tomorrow.
the best thing you can do is just you take that example, whatever is given, and you execute the code by yourself. Then only you'll get it.
Yeah,
Sir,
it's pretty
Bit,
simple now if you get that answer.
uh,
But after
sir,
that, how
yeah.
can I execute the?
sir, are you
How can
ending
I
the
write
session,
the
sir?
ascending order? That's my doubt.
Okay. Sir, are you ending the session, sir?
Sorry. Yeah. Yes,
Sir,
I'm searching.
one
So
doubt, sir.
someone
This
asked, how can you?
so this question number 11, sir, in the same, sir, graded assignment 11,
Yeah,
sir.
exactly. Question number, just the pseudo code of that.
No, I'm not able to get it, sir, of DFS tree.
It's totally depend
This
on the
one.
value of I that you have. If you see, the value is 3, so it's starting from 3. No, not 3. APSI, and I
Okay.
is equals to 3.
Okay, Arman. Let sir speak. Sir, continue, sir. Please explain, sir.
Okay. Okay. So here, execute the following pseudocode. They're saying, and options are this. P is the initially empty dictionary, then S is the list, then P3 is -1. Okay. So your P is something here is a dictionary. Let's not close it here now. And S is a list. S is a list. So let's not close it also now. And then P3 is being -1. So 3 will be -1. And its parent is, so initially parent is equal to 0. Okay, fine. Then P comma S is DFS of AP, S, and 3. Okay. Where is DFS function? DFS function, where it is defined? Is it earlier? So see, to solve this, we have to see the function also. DFS, I know what it does, but particular implementation we have to see to solve some question. So it is taking a graph and a parent, and like this parent is basically from where we need to start, and a sequence. Okay, fine. Sequence is will do something, and then I. Sequence is equal to sequence plus I. That means in the sequence they are adding I for each j in column of the graph. I mean, taking column or row is same. And if graph of ij is equal to 1, then and not is key of parent comma j. Parent is a dictionary I want, that's why we are applying. If if J is not parent of, sorry, what it's called, if J doesn't exist in this parent list, then parents of J is I. Okay. Yeah, of course, because jth column they are checking. Then parent and sequence is again applying DFS of graph parent sequence instance. Okay, because see, it is applying DFS because DFS is like, as you know, that first it will always call the function iteratively. Okay, so again, so parent sequence and J. Okay, so it will do the same operation. Okay, and finally it is returning parent and sequence. So parent and sequence. Parent sequence, it will add all the elements which can be reachable in the column. If it is one. Okay. Therefore, let me go here. I mean, yeah. So DFS with no, not this one.
Question 11.
Okay, so in DFS they are passing A. A means your graph, main graph, right? Okay. So B is the matrix representative of which of the following graph? Okay, so in reverse way you have to go. First we have to see what is the matrix being prepared. Okay, so matrix will be prepared. We are applying PS and DFS of A, P, S, and P. P is initially 0. I mean, I have to go multiple times here in the DFS function.
I will tell you the matrix, sir. 0, 1.
Okay. Sorry, matrix.
Yes, sir.
Matrix 0, 1.
0, 1.
0, 1.
0, 0.
0, 0. Then
1, 0.
1, 0.
1, 0.
1, 0.
1, 0.
1, 0. Then
Yes. 0, 1.
how many nodes are there?
Sir, 6 are there.
0, 1.
0, 1.
Again 0, 1.
Yes, sir. And again 0, 1.
Okay. 0, 1. And
Then 0. This is third. This is 1, 0. And again 1, 0. And
0.
2, 0.
2, 0.
No, sir, not
2,
2.
0.
Sir. 2 times 0, sir. 0, 0.
Okay, okay. Okay, fine.
Sorry, sir. 0, 1.
0, 1.
And rest all 0. Yes. 0, 0, 1.
You could have said 4, 4. It is not 1, 2, 3, 4, 5. Okay, 1, 1. 0, 1.
0, yes, 0, 0, 1. 2 times 0 and then 1. And then 3 times 0. Yes. Yes.
Okay. Now for each I in keys, create matrix 6, 6 they created. Parent of Pi, value of parent I equal to 1. Okay, let me digest this code first. For each I in keys of P. So P will get all the nodes, if I'm not wrong. Is it? I mean, you solved this, so you can say P is all the nodes. Is it? Hello. This here.
P is parent element, sir. Parents. Yes, sir. It is a node only.
So it will have all the nodes. Okay, basically, what parent of Pi. Parent is equal to Pi. So its parent and parent of, so basically what they are doing for each of the node from the row, what is the parent? Ith is parent or not? They're trying to say. So for a 0th element, 1 is parent and 3 is parent. They're numbered from 0. So 1 and 3. 1 and 3. Is there any place where for 0 or 1 and 3 is there any structure like for 0? Is there any structure like 1 and 3? No, sorry. Yeah. Is there any structure like this? Anywhere? Oh, it is that seems it is not possible, even possible. So if you see here, 0 is
Sir, like
I hope this is super parents also considering. So for C here, I actually don't know in BFS how they are calculating this parent thing. So I have to spend some time to understand. But what I'm guessing is that it is also considering the super parents, not only direct parent, it is also considering the super parents. So for 0th node, see in first index there is 1. That means it's parent. Okay. And third there is parent. So I can relate this here as this since this is directly coming, it is a direct parent. And then with 3 nodes after that 0 and 3, uh, it is super parent in some way. Okay. So this is again, since this is connecting uh, with this arrow, I mean for 3, everyone is child. Okay. So in this way, if you check, okay, someone is saying something.
Sir, our
yeah.
source vertex will be 3, right, sir? We will start our
Sorry?
BFS tree with 3, right?
Sorry.
We will start our tree with source will be 3, right? Because in the pseudocode it is given the parent of 3 is minus 1.
Here it is given.
After that, sir, how will initialize? After like
Sir, that parent of 3 is equal to -1. Like what it is actually telling us, I do not understand that.
It is telling there is no parent for 3. Actually,
What?
there is no parent for 3.
Acha, okay. Okay, yeah.
So,
And then this if I is not like equal to 3, that line 7.
line 7, they are saying like if it is not the root. I mean, in tree terminology, sometimes it is
3 should
called
not be
root.
the root of the tree. That.
I mean, if it is uh, 3, the third node, then uh, there should not be any parent for him, right? So that's why they will skip this part. I mean, what they're setting here is that the parent relation, right? The parent relation,
What
they are
actually we
storing,
want to find?
they are finding the parent relation here. Okay, in this
sir,
code. So
sir, it will be
if
better
we
if you
do,
write the yes, sir. Sir, you write 0, 1, 2, 3 over here, sir, outside the matrix, so we will be able to relate.
okay, let me okay. So see, without looking at the matrix or the graph, we cannot exactly write, but since it is parent, I can say there will be no incoming edge for 3. Okay.
Okay, sir.
Okay. So I mean, here 3 will be the root node. Okay. Then in this relation, sorry, in this table, you store 1 if there's a parent for this particular node. Okay. And see, if this your 3 should not have any parent, that's why if the I is equal to 3, then it skips the process here. That is
So
it only.
basically, we are finding
Okay,
that there should not be any parent for 3. That 3 should be the root vertex.
So in that
Yeah, got
sense, here this is 0, this is this sorry, this is 1, this is 2, and this is 3, where itself is 1, and then there is again 2, there is 1.
So what I'm understanding is, basically this I represents the row. So we will check the row except this fourth one. This
No,
3.
I do not represent row because I represent here. You can see I is in the second this bracket, so it's column only. So first one will be a row, second one will be a column. Okay, give me some time. I'll read the algorithm, and then I'll try to understand what they do. There's any. Okay. Give me 2 minutes. Our P was a list, right? And S was set. Sorry, P was parent, so I can get it from here. Sequence, yeah, sequence was a list, and P was a set. Sorry, dictionary. So initially 3 will come here, and then we can go here with 3. Oh, this is a reverse actually. So on which graph they applied this? Our A graph is not given initially, right? Can you tell me what is A graph? No.
What?
So
The
This
above
graph,
graph only.
which is what is this graph? This graph only.
yes.
Yeah, this one.
Okay. So first our 3 will come. Okay, fine. Then from 3 the adjacents are they mention any order how to take if I have options to choose. Say now from 3 I can choose both 0 and 2. Which one to choose? They mention anything like any
No,
order
no,
or
there's
something?
nothing like that.
Oh, then it should be
Wait,
mentioned, right? Consider the following graph which composed of the agent that is already completed.
No, there's not nothing like that.
So let's consider 0 in the ascending order. If I take 0, then what will happen? As of now, our parent is empty. So if we apply J, it will be empty, it will go inside. Parent of J is equal to I. So parent of J
Today
will be
morning, sir, I was watching
0.
this grade 7 lecture, sir, of this Archit, sir. He simply
Sorry?
made this. Sir, Archit, sir, said today morning I was watching his recorded lecture. I was not able to understand, but somehow I tried to understand. Like he simply made a urgency metric and then he calculated he made the tree out of that matrix. What he did was he said that the tree has a parent of -1, and after 3 he went to 0, and in matrix he updated the value to 1, and from 0 he went to 1.
Oh, initially, this 3 is -1, right?
Yes, sir.
Okay. So
And from
now,
so from
let me grab it.
you can sir draw this tree over here, sir. What he did, I will explain you better, sir. We can catch from there only.
Sir, in the solution, that solution PDF, so you are having that only. So there they have given that P parent set or list. Sorry. You can check that.
In the solution.
Yeah. Just go down. Last page.
Nothing is there. I think.
It's not here, but it's like it's there in the solution. Shall I just tell you that?
Yeah, you can share your screen.
The P dictionary, like not the screen. Shall I just tell you the elements of that, the dictionary?
Tell me. Okay, you tell me both P and S.
No, like for the S they have not given. Just for the P, it's here.
Better share the screenshot.
Okay,
Sarah.
S. Yeah, S is. I think I don't need. Yeah, tell me P. Value of P. Okay, well then.
Shall I tell you or just send the screenshot? Because like now I'm on my
No,
laptop,
you
so
tell
I have
me.
to connect from phone. That's why I was saying.
You tell me.
Yeah, okay, wait. So P, like the
3
dictionary.
is -1.
No, what?
3 is
3
-1,
minus
right?
1. Yeah. Then 0, 3.
And then
0
0, 3,
key and the value is 3. Then 1, 0.
0,
2, 1.
1,
5, 2.
5, 2.
And 4, 1. That's it.
4, 1.
Yeah. So this is the parent dictionary.
Okay, fine. Let me know.
And also from the solution, I can understand this one thing, that it's the pseudocode is telling us that 3 should like there should not be any edge directed to 3.
Yeah, no incoming
That is the
edge.
one thing we can conclude. So like using this information, if we'll go to the solutions, like if we'll go check out the options, we can clearly say that B is the correct answer using that.
But for A is also there is no edge coming incoming
Yeah,
edge for
A2, yeah.
Mm.
Yeah.
So let me just try this matrix now.
But sir, the parent of 2 is not 3. According to the code Sarah gave, the parent of 2 is 1.
Okay, yeah. So this age doesn't make sense. In
Yeah,
the
0 will
second,
come.
is it like this? Yeah.
Yeah,
So in
it's
second,
correct.
Mm-hmm.
okay. So let me just create this matrix here. I mean, oh, someone already give me this that matrix. Uh,
Yeah, I will give you. So this was what Archit sir directly did. What I didn't understand how he created the matrix.
mm,
He did not write this
this
with
Like we made
uh, oh,
this matrix using the graph he had, na? He also made it like using that only, na?
no, but we will have to eliminate few edges.
Yeah, in the solution also they have said to like made this adjacency matrix.
okay. So first, I is equal to I in keys of P.
But one more box will
So
come. So
3,
there are total 6
1, 2,
values:
3,
0, 1,
4,
2, 3,
5,
4, 5.
6. Okay. Yeah. So if I not equals to 3, then we'll go inside. And first time it is 3, so we'll not do anything. For the next key, 0, 0 not is equal to 3 is 2. So we'll see parent of
Second,
PI.
can you please number
P
sir
of,
this matrix? Sir? It will be easy for us to understand.
sorry? Okay.
0.
So say
Yes.
0, 1.
Yes, sir. Thank you.
So now P of 0 is what? P of 0 is 3. Okay. So P of 0 is 3 means the parent will be 3. And then B of 3 of I means 0. 3 of I 0 will be 1. Okay. Okay, so that is the other way I understood. I was looking from this way, this to, I was making relation this to this. This relation this to
Sir,
this.
just wanted to ask, like, is it necessary to make this matrix like adjacency matrix?
Yeah, after creating only this only you can also, I mean, see, if you have any hint, then you can go ahead, but that is a risky business, right?
Mm-hmm, yeah.
This matrix
Creating
will give
this
a
adjacency
proper
matrix.
idea, sir, that where the edges are connecting.
Uh, so
So like if the question like this comes in the exam, it will take like half an hour for this only. All these
yeah, I
steps.
don't think this kind of question they'll ask. I mean, it's true. It took for me also to understand.
Yeah, first even like it will take 15 minutes to understand what actually is happening and then just to do all this over.
It's true. I mean, I don't think this kind of question will be asked in sorry, exam. So now this graph means there will be age from here to here. Okay, from 3 to 1 in some way. Okay, then
No, sir. I think this 3 to 0 there will be edge. From 0 to 1 there will be another edge.
oh shit. Yeah, my mind is not brain is not working properly.
Okay.
Okay. Yeah, so 3 to 0 we as in first column only put na, so yes, from 3 to 0 will be there. The next what is doing okay, next key it is next key is what 1
1 to 0. Yes.
so,
0 is parent of 1.
for 1
So from 0 there will
for
be S to 1.
1, so 1 is 0. So
Yes, sir.
it will be, I mean, parent will be 0, right? So 0 to 1, it will be 1.
Yes, sir.
And then, okay, it is same matrix, so what you told me, right?
Yes.
Okay, then
But
for
sir,
next
here, sir,
one,
few edges will get deleted over there. Sir. I checked. It is a DFS tree, sir. It will check the shortest path.
okay, no, it will be a tree then.
Yes, sir. Yes.
Uh,
After
okay,
1, sir, we go to 2.
yeah. So 2, if we take 2, then our I is 2. Okay, that's, I'm getting confused. I is 2. So P of 2 is 2. Where is 2? 2 with 2 as a key.
The parent of 2 is 1, sir.
Right.
So, yes.
So yeah, parent of 2 is 1. So parent is equal to 1. So for
From 1,
1, 2.
there will be S to 2.
1, 2.
Yes.
This one, 1. Next is 5. So our is equal to 5. 5, it is true. 2. Give me 1 second. So here 5. For 5, 2. Here it is 1. Then for 4, it was 1, right? For 4, it is 1.
Sir, from 2 it will go to 5 now, sir. 2 is the parent of 5.
Oh, sorry.
Yes, sir.
Then it was 2 to 5. And for 4, parent is 1, and 1 to 4. 1 to 4. It's correct, right?
Yes, sir. We came back, sir.
Yeah.
After there was no a parent of parent of 5 was not. 5 is not a parent, sir. So it was an end. So we moved back to 2, and then from 2 we moved back to 1.
Sorry. Can you tell me again?
So 5 is the last point, sir.
See, from here, no, from here you can stop. This 4
Can
is the
you
last
scroll
one,
down,
right?
sir? Can you scroll down, sir? Option B, sir. Option B.
No,
Option B.
I'm saying this
Yes, sir.
matrix creation till here is done.
Yeah, it is done.
Okay, but I think last time when you told me there were more ones.
Yes, sir. That's what I said,
Okay.
sir.
So
When we create a
from here,
DFS tree, yes, sir.
from here you try to create the matrix. Sorry,
Yes.
tree. So from 3 to 1, right? 3 to 0. Okay. Somehow something will something may come in between. So okay.
From 0 to 1.
From 0 to 0 to 1. So from 0 to 0 to 1. Then
From 1 to 2.
nothing is there. From 1 to 2.
From 1,
to
2 edges will come, sir. 1 to 2 and 1 to 4.
1 to 4.
And from 2 to 5 it will go. 5.
5. 2 to 5. Yeah, that's it only, I know.
Yes.
30124, 30124 is the same 30124, 5. 124, 5. Yeah. So this B is correct. Yes, sir.
So it is correct.
Yeah. So here only you can stop and create the graph. I mean, of course, this graph is not correct. You have to put these directions. Yeah. Okay. So yeah, it was interesting question actually.
Yes. I'm sir still confused in this, sir. Like if we consider this grandparent thing and when how the graph will change, it still confuses me, sir.
So sorry. What? No,
Am
from
I
here
audible,
only
sir?
you can connect it.
Yes.
Yeah. So from here only you can see now which is connected to what.
Yeah,
So
yeah, sir.
earlier, see, grandparent thing is I was not aware of. I didn't understood the this BFS function. That's why I said this grandparent thing. But here you can see for 1, 3 is a grandparent, right? I mean that is not something we have to care here.
Even it's not mentioned in the question
Oh.
also. So
Exactly, it is not mentioned.
I basically
So,
struggle with this creating a matrix of this tree, sir. Initially, that Sarah told this this dictionary, right? No, sir. I was not able to make this one, sir. I don't know what Archit sir did. He simply read this code and he created this matrix. It was very confusing for me to understand.
Anyway, this matrix and that matrix was same or what?
Sir, few elements, the entries are not present. Like one, there are few in earlier matrix. Even 4 was having one, and 5 was also having one. Here it is not present, sir. I mean, of course, we are drawing the DFS tree, so the number of edges will reduce.
See, no, I mean, see, you have to follow the pseudocode, right? I mean, I don't know what he did, but if I follow the pseudocode, this is what we'll get.
Yes, sir.
This is
Maybe, sir.
only what we'll get.
A little bit confusing questions, sir.
I mean, I don't think this kind of tough question will be asked, but I mean, if you follow the pseudocode, this is only. I mean, even you can see answer is B only, right? And B and this graph is exactly same. I hope.
Yeah. Yes, sir.
This graph. So if you change anything here, graph will change. Say, suppose example, can you tell me any one which is present here in this that matrix, but not here? Can you tell me any matrix? Say in the
Just
fifth row. Can you?
5th row, third column.
Third column means here or where?
Here, yeah, correct.
Or here.
There only, sir. There, no, sir. Earlier, where you close, sir. Third column, sir. Third column.
This one.
Yes, sir. There is a connection from 5 to 2. It will become a 2 undirected matrix in that case.
I mean, see, it is not possible. I don't know why he did this, but see, I've just followed the pseudocode in front of you, right? So what
Yes, sir.
basically, if you see the root pseudocode, in pseudocode, each key is taking from this P, correct?
Yes.
If it is not 3, then it is going inside, taking the parent and updating parent of I is equal to true. Nothing extra statement is there. I executed all the statement here.
Got it.
So it is not possible that here you'll get 1. It is not. I mean, if some matrix is given, that is wrong actually.
If the interpretation is, I take the interpretation of this matrix, sir, 2. If we take an edge from 2 to 5, we say that the parent of 5 is 2. But if we put an entry 1 over here, we also said that 5 is also parent of 2, which is not possible.
Yeah. So yes, that is only. You follow the pseudocode, you'll get the answer.
Yeah. I'm not able to understand. I was not able to understand the pseudocode only. Thank you, sir.
Okay.
Thank you, sir.
Okay. Thank you everyone for joining this session, and all the best for your exam. Tomorrow you have an exam or something?
1st September.
Okay. So from tomorrow, maybe some other batch.
Yes. Sir, when we will discussing, sir, this mock assignments, mock test.
Mock maybe Monday.
Okay, sir. Thank you, sir. Good night, sir.
Okay.
Yes.
Okay. Good night, everyone.